If you've ridden the subway in places like London, Hong Kong, you've probably noticed that if you're at the street and you're trying to get down to the platform or vice versa, you really have to go through an entire labyrinth of escalator rides and corridors. It's almost like a hedge maze or something. And other cities are much closer, like Budapest or Paris, where it's closer to the surface. But in New York City, they obsessed about getting the subway as close to the surface as possible. And can you guess why? It's not a trick question. It's just more convenient. It's fewer steps. And as someone who lives on a fourth floor walk up, I definitely appreciate that. And in this case, I think what's even more interesting than their reasons for doing it were the lengths that they went through to achieve it, to get it as close as possible to the street surface. Uh, that's what today's episode is about. Barely a subway. Why the New York City subway was designed to be so close to the street surface, and all the things that they did to get it as close to the surface as possible. So, welcome to Making Infrastructure Pay. I'm Kyle Kirschling. I'm a CPA, a city planner. I spent over a decade working for the New York City Subway. And now I'm a transportation consultant. I'm really interested in, I love infrastructure, but especially where infrastructure and economics come together. I love the history and thinking about the future. And my goal is to help people better understand the value of infrastructure and show ideas about how it can be made even better. And as a disclaimer, these ideas are my own. They're not those of any current or former employers. So today we're talking about why the stations are so close to the surface. This is part of a series on subway design, and this is the third part in the book, which you can, it's a paper, which you can get. The link is in the notes below. But this is the third item, and we're talking about the original design that really came together in 1891 and which is reflected in most of the New York City subway as it exists today. So if you're not familiar with the New York City subway, it is pretty close to the street. Something like this, where right below the utilities in the street, you have the subway trains. If you're walking down the street in most places, you hear the subway trains, the wheels squealing, through the vents. Before they had wireless service in the subway stations, like some place I could even get a signal on my phone because it's very close to the surface. It's right below. And as we normally do, I like to start by looking at what were the alternatives, what were the other options that they could have chosen instead of, for instance, making it so close to the surface. And in this case, it's a deep tunnel. And I think it's just a lovely illustration from 1891. It's not, the perspective isn't accurate, and it's a little bit cartoonish, but it's very clear and lively, almost like a children's book or something. But this was a proposal by Austin Corbin, who owned the Long Island Railroad. And again, this is the kind of thing that they were thinking about. It's pretty deep down in the bedrock. This is the line of bedrock. You've got all these elevators bringing you up to the street. And in this case, the express trains would have been on a lower level, the local trains on a higher level. And again, very deep underground. And there are a lot of advantages to this kind of system. And it's the way most newer subways tend to be built, deep down like this. Just as if you're interested, this is a map of where those lines would have gone. It would have, instead of at this time in 1891, Long Island Road did not have a connection into Manhattan. And today's Atlantic Terminal would have been extended into the Lower Manhattan in New Jersey and had several lines around Manhattan and the Bronx. But the advantages of this deeper tunnel, they believed it would be cheaper to construct, although they weren't. It wasn't entirely clear to them whether it would be, but they thought it would be. And the reason they thought it would be is because it's much simpler to build. Therefore, it takes less time and therefore costs less money. And in particular, it avoids relocating the utilities. You don't have to touch anything that's in the street here. It can all stay, and you dig the tunnels well below that without affecting what's in the street today, or at that what's in the street. And there was a lot of stuff in the street. So this is a diagram of an intersection as it was in 1890, again, right around this time. And there's a lot, and there's pretty much the same things underground as there are today. You've got, but this time, electric wires were underground. You've got gas, water, sewer, and you've got a few other things. You didn't have fiber optic cables, but you have some other things that we don't really have so much today. You've got the streetcar tracks and the cables. A lot of them at this time were cable driven, so these spaces for the cables to go through the streets. You've got pneumatic tubes, which are quite sensitive, and so those are particularly tricky. And you've also got elevated railways over some of the streets where they were going to build a subway. So, and here's just an example of when they did build the subway. Right below the surface, you can see how they had to just completely open up the street and completely remove all the utilities that were there. And this picture shows how they had to prop up. This is a stairway going to an elevated station, and they put these beams in and have heavy timber. So they had to do all this work to support this. But if you did the deep tunnel, you don't have to worry about any of that. So in addition to that, it also would have been safer for building foundations. Because again, especially if you're in the bedrock, the buildings are on top of the bedrock. You're not going to be affecting any of their foundations. So that was a big concern at the time, especially because New York City was now starting to build skyscrapers and these big heavy buildings. It was concerned, well, what if we rip open the street and it causes subsidence? And just the lack of street disruption in general, obviously, is an advantage. Again, this street is completely ripped open. If you live there and it's like that for a couple of years, it's probably, I don't know, it's hard to imagine what it would be like. It may be exciting to watch, but I don't think most people would feel that way about it. As a sidebar, because I think you might find this interesting, this here is often referred to as cut and cover, where you cut a trench into the street or wherever you're going to build the tunnel. You put the tracks, you build the tunnel, and then you cover it over. Cut and cover, as opposed to some kind of deep tunnel construction with like a tunnel boring machine or a shield that you drive through the rock or the mud or clay or whatever it is, whatever the materials that you're driving it through. So it's often some kind of deep tunnel versus cut and cover. But at the time, cut and cover was actually an innovation. It was distinct from, this was actually just open cut, where that's what this is referred to as, where you build the trench, you build the subway line, you lay the tracks, and then once you're finished, you cover it over with the street. So that was just open cut construction. Cut and cover actually was distinct from that. And it was an innovation in the sense that what you would do with cut and cover is you would first, just peel away a layer of the street. You would have to, just the top layer, essentially, the pavement. And then you would sink these heavy timbers down below to the level of where the foundations would be for the subway. And then you cover it over, you build a street on top of it with planks or whatever. And then you come in and then you excavate and you remove all of the material. And then you build a subway. So you cut it open, you cover it, and then you do the construction, and then you put the final street on top of it. At this time, cut and cover was actually a little bit different from open cut. The first subway was just an open cut. That's what this is showing. But then afterwards, because this was so disruptive, they then advanced to cut and cover, where you do the excavating and the construction after you've built a temporary street over it. And this deep tunnel alternative that we're talking about is very common. Again, most newer subways are this way. Most of London and other tunnels in New York, like for the Pennsylvania Railroad and things like that. So why did they make it so close? In this case, it's pretty clear. There was one main reason that was driving it, and just that they wanted to make it was more convenient, right? It's more accessible. It's easier to get to. That was by far the main reason. The great advantage of this form is the reducing of the distance from the platform to the street level to the minimum, thus rendering access most easy. The disadvantages are inconvenience to abutting property owners and to street traffic during construction, and the necessity for and expense of readjusting all sewers and mains to counter all along the route. But I like this expression, thus rendering access most easy. Indeed. And this trade-off between ease of construction and the convenience of the completed line exists to this day. So this is coming from the environmental impact statement for New York City's 2nd Avenue Subway, which opened less than 10 years ago, or the first segment of it opened less than 10 years ago. And they're explaining why in the final impact statement, the ridership numbers projections were a bit lower than in the draft environmental impact statement. And they say, in many cases, stations would be deeper than originally projected to reduce surface construction impacts, and entrance times are longer, making the new line slightly less attractive to some riders. So in other words, to minimize disruption to the street, they built it deeper. That means it takes longer to get there, which means less people are going to ride it. So it's the same trade-off. But interestingly, they took a very different approach in 1891 in the early 20th century. It is admitted by the strongest advocates of underground transit that, other things being equal, the nearer the station platforms are to the surface, the more attractive the line. Conceding, however, that there are some advantages in deep tunneling for Lower Broadway, and here they're talking about soil conditions. It is seen that these apply entirely during the time of construction and to the first cost of the structure. These, while important, cannot weigh against permanent advantages to be derived in comfort and convenience to the public, facility of operation, and the securing of patronage after completion. Ready accessibility by means of short, broad, and commodious stairways, supplemented where necessary by elevators, better light and better ventilation at stations, light and air at intermediate points if necessary, and the feeling of greater security on the part of the public with the structure which can be more readily reached in time of accident or other emergency are too potent to be surrendered to mere temporary difficulties of construction. These and other considerations led to the decision upon the part of the commission to place the underground structure as near the surface of the street as possible. So again, it's interesting. It's the same trade-off, but they're very clearly in the other camp. They are saying, mere temporary difficulties of construction. Now, the other aspect that's significant, which is really a part of this convenience aspect, but it's about profit and making this system pay for itself. Now, in another video on speed, I talk about their goal of trying to make the city limits accessible within about a half an hour. And you really need a high-speed system to do that because they want to allow the city to expand and to allow people to encourage people to live further out where they can, because of concerns about density and crowding at that time. They thought that you'd have better quality housing by spreading out. So part of that was not just to be fast, but to have a flat fare. There would be a flat 5-cent fare, not distance based because they did not want to discourage people from living further out. So you have a flat fare, but if you're running a passenger railroad, main, at least the way it was conceived at the time, and I think it's probably still largely true today, the main driver of your operating expenses is the number of car miles that you have to operate. So a car mile just means if you have one passenger car going 10 miles, traveling 10 miles, that would be 10 car miles. A 10 car train going 1 mile, that would be 10 car miles. So this the number of miles that you're moving a car, that's sort of the main driver of your operating expenses. But you're only charging, but the fare is flat. It's just per ride. So the longer the average person travels, the longer they ride the train, then that means you're going to need to operate more car miles if you want to maintain the same level of crowding on the train. Like, let's say you want to have a seat for every customer. Well, if people are on the train longer, they're going further, and you're going to need more trains to provide that same amount of service. So you're going to have more expenses. So what this means that the local trains are going to be subsidizing the express trains, and they need those express trains to get that speed to make it accessible. But they're actually going to make more money on the local trains, and they need the local trains to subsidize the express service. That's part of the whole scheme. That's part of their whole design. So that means that you need to make this attractive. It's really important for the financial viability of the whole thing to work. You need to make the local service very attractive. You want to encourage people to take short trips because that's how you're going to pay for the express service that you need. On the face of it, it appears to me that a shallow tunnel is undoubtedly superior to a deep tunnel because it is easily accessible and saves the time and inconvenience of getting up and down in a deep tunnel with elevators. The time lost in the latter way would be sufficient to enable passengers to ride several blocks, and it would be detrimental to short trips. So what they're saying is if you could just get on a streetcar and you'd be several blocks away by the time someone taking the subway even gets down to the platform. So you wouldn't do it. You just take a streetcar. And detrimental short trips, so you're not going to get short trip riders. If the road is a few feet below the surface, passengers can quickly descend and ascend, and it would be a savings of time and more desirable in every way. Or here, it is not believed that a deep subterranean line of transit with elevators would attract short trip passengers, and the short trip business is absolutely essential for the financial success of any line, the cost of which at all approximates that of a 4-track tunnel in New York City. And I think that's pretty clear that if you look at this design, for instance, even these local trains, you're going to have to, it's not going to be nearly as, you're going to, why not just take a streetcar unless you're going, it depends on how far you're going, but this is definitely going to be less appealing to have to get on, wait for an elevator, go down, and compared to just here where it's just a few steps down. So there's this profit element, which is, it's part of why it needs to be convenient and accessible, but there's this really important aspect to make it, the whole thing, financially viable. And then there were a few other things that they mentioned, which were smaller, but they do talk about them. Emergency egress, people traveling underground there wasn't much of that. So there were concerns people might not feel safe. So being able to have lots of emergency exits. New York City, the stations have lots of exits. There's emergency exits between almost every station as well. So the system is sort of blessed with that. It is easier to ventilate it. The closer to the surface, easier to ventilate. You can even have natural light in some cases. You're not reliant upon elevators. And another thing is they were concerned about the building foundations, but they also realized that if you're deep down, you're below the foundations in the rock, you're not going to affect them. On the other hand, if you're up close to the surface and you don't have to dig below the foundations of the buildings, you're also probably in a pretty good spot. If you can say either really, if you want to be deep down or really close to the surface. So there was a certain advantage for being able to stay above the bottom of certain building foundations. But the main reason was really this convenience aspect, and especially the subcategory of profitability, making it lucrative. So now, like, the lengths that they went to achieve it, I think are just fascinating. So this is from the original design in 1891, because it evolved. And here you can see what they were first imagining was that they would come in right below the existing utilities. They wanted to not open the street originally. They thought they could build it without disrupting the street and come in right under with some kind of a shield or something and just kiss the bottom of the utility. So they wanted to get as close as they could right up to the bottom of it without having to rip open the street. But they soon realized that wasn't going to be practical, that you were going to just have to open the street. And so at that point, they realized, well, if we're going to have to open up the street, then there's a lot of things that we can do to make it close. And the limiting factor essentially were these yokes, because it's sort of shaped like a yoke. It's what contains the cable for the streetcar. So there's the rails above it, but then the cable would run through here. And then later, when they made it electric, they used that same space for the electric lines. But I believe but they were originally built for cables. And so it was owned by the streetcars. They couldn't really move it. And so there's this minimum of 30 inches. So that's like the limiting factor. And then they do everything they can to get as close to the surface as they can with that limiting factor. And so one thing they do is, you'll notice, now this is a cross section of a street with the subway. There's 4 tracks, 1, 2, 3, 4. So you're looking down the tracks here. And you can see there's a column between every track. And that was made because by having the columns between every track, the beams don't have to be as thick, right? So here, for instance, where they had to stack it because of space, when the beams span this longer distance, they're thicker. They span a shorter distance, they're not as thick, so they can make it closer to the street. So they made this deliberate decision to design it that way. In designing the structure, it was decided to secure the absolute minimum of depth, the allowed limit of clearance between the street surface and the top of the subway being the depth of the yokes of the surface of the electric railway, which was 30 inches. The roof of the railway was made as flat and as thin as possible. To meet the latter requirement, columns were introduced between each track so that the roof beams need to be deep enough to span but one track only. Now, there's another decision they made. They looked at building an arch type tunnel. So this is a drawing from the Metropolitan and District Railway in London. And this was built, I believe, mostly by an open cut or type of system. The street surface, it's right below the street surface. It's not a deep tunnel, but it's a brick, and it's like a brick arch to support it. And it's very sturdy design. But can you guess why? Can you see the problem here with this? Yeah, you've got this, you're wasting this space. So this would otherwise be totally satisfactory design. But again, they rejected this explicitly because you have this extra room up here, which is going to mean the tracks have to be just that much further from the street surface than they otherwise would be. Another thing they did was how they relocated the utilities. So this looks like Broadway. I'm not sure where this is, but this is where they're building a subway, and it looks like it's mostly been complete. It still has this. The street hasn't been totally rebuilt. It looks like it's some kind of temporary street, but they have these pipes going over the top of the subway. And what they're doing here is they're taking one, I think this is water mains, but I'm not sure, one main, and then they split it into 3 to make it thinner so that it can fit within that 30 inches that they have to work with. So I just think that's really amazing, like taking one, split it to 3 to fit it over. And here it almost looks like they're taking 1 and splitting it into 2 for something else, but I'm not sure what that is. Just one other thing I think is really interesting, just to see the lengths that they went through, how obsessed they were, in a good way, with making it close to the street surface. So this was another part of another idea that they were really seriously considering. They ultimately rejected. But what they've done here is the tracks are on 2 levels. Instead of being on 1 level, they're on 2 levels. But what you can do is, by stacking it, you can create this space in the center where you would put the utilities. They call it like a pipe gallery, which just seems a funny term, but a pipe gallery. And then you could push the trains to be even closer to the surface because you don't have the utilities running up here. And you also sort of solve the problem of the streetcar yokes because you're outside of it, in most cases. So this allows you to push really close to the surface. And that was why they were looking at this. Then, and here it's 19 steps. Another part of this design is they came up with a different type of car, coach car, passenger car to use that was it had lower height. So it's sort of like a low floor bus, so that the wheels would come up into the body of the car, making it shorter and then allowing the platforms to be closer to the street. So you have this bi-level design, it's just really interesting, and there's actually a lot of advantages to this kind of design. You could easily make any station you want into an express station. You could easily close one level and not the other, and vice versa, to do maintenance, things like that. You'd have the pipes organized into the gallery, and even closer to the street. But you could probably see the problem with it. One, which you can't, as they see from the drawing, is that they were not comfortable with the idea. At the end of the day, they're not comfortable with the idea of creating this space for the utilities. The board had the authority to relocate utilities and to build the subway, but this was more sort of beyond just what you needed to build it, and more like creating a whole system where you'd be responsible for maintaining it. You would own the space where all the utilities are. So that seemed to be a step beyond the spirit, at least, of their authority. But then also, the express trains are on this lower level, and even though the local trains are even closer than the design they chose, the express trains you've got to go a whole another level down. Not that much further, because it's so much closer with the savings of space here, and with the low height cars. These are like about 4.5 feet shorter, I think, than a conventional car. But still, it would, and plus you have to use stairs to transfer between the local and express. So they rejected this, but they really were thinking about trying to come up with all kinds of ways to make it as convenient and as close to the street surface as possible. It's really kind of incredible. To sum up, they chose a design to be right close to the surface, and they really pushed it to the maximum. The main reason really for doing it is they wanted it to be convenient, accessible, rendering access most easy, versus mere temporary difficulties of construction. So, as part of the reasoning for wanting to make it convenient is not just to make it a great system, convenient to save travel time, but to attract short trip riders, to make it convenient for people who are going to ride a short distance, pay that flat fare, and thereby help subsidize the essential express service. So to make it pay. So that's our show for today. Until next time, I'm Kyle Kirschling. Thank you guys for listening. I can't believe it. The 4-track video has almost 10,000 views, which is amazing. All right. Have a good day, guys.